Determining asymptotes. We have three asymptotes here. The first one is the vertical asymptote. And the second one would be the horizontal asymptote. Horizontal asymptote here. And the third one would be the slanted asymptote over here. Okay. Um, I'll give you a chance to read the definition first of the three asymptotes. Okay, let's start with the vertical asymptotes. Find any vertical asymptotes by setting the denominator equal to 0 and solving for x. If if a is 0 of the denominator, then the line x is equal to a is a vertical asymptote. Now, what do you mean by the word asymptote? Now, it's a line that passes through the broken part of the graph. Or you can say this is a line that continually approaches a given curve but does not meet it at any finite distance. So this line is like a division of the graph from the left and the right, or from the upper and the lower part of your graph. Okay, so this is where your equation as a rational function will become undefined. So when you have the bottom equal to 0. Okay, so let's have an example here, finding the vertical asymptotes. Example, I have your f of x equals 1 over x plus 1. Now note that the top part of the term, it's a 1 that is equivalent to x power of 0. So you have a degree 0 there. And the bottom is x plus 1. You have a degree of 1 here. So the top is lesser than the bottom. Okay, and the rule here, when you're trying to find the asymptote, it says you have to set the bottom term equal to 0. So we will take the bottom here equal to 0. So that would be x plus 1 equal to 0. And x is equal to negative 1. This is our vertical asymptote. Okay. And the second rule here, if the numerator has lesser degree than the denominator, so that's what we have here, you have lesser degree by 1, then there is a horizontal asymptote, y is equal to 0. So our horizontal asymptote here is y is equal to 0. So this is our horizontal asymptote. If you're going to be asked, do you have a slanted asymptote here? The answer is none. If there is horizontal, there's no slanted asymptote. Okay, so note of these two equations here. X is equal to -1 and y is equal to 0. And then we will graph this one. So you can see the part where the graph is broken. Okay, so we are now in the graph, and then we can plug that in. Y is equal to our f of x1 over x plus 1. So our answer for the vertical asymptote was x is equal to -1. So you can see the blue line here represent the asymptote, and this is a vertical line passing through the broken part of the graph. So that point actually is -1. So as you can see, the graph is approaching this blue line here, but never touches that line. So when you go up, it never touches also at the bottom. Similar to the right side, the left side curve is approaching to the blue line, but never touches that line. Because what happens if you will touch that? When you have a value of a -1, you plug that in here. At the bottom, you have a -1 plus 1, you'll get a 0 at the bottom. 1 divided by 0 is undefined. So that means you cannot have a value of a -1 for your graph. Then according to the horizontal asymptote rule, if the top has lesser degree, so 1 here can be represented as x power of 0, and the bottom is x power of 1, so the top is lesser than the bottom. So you always have y is equal to 0. And you can see that is the x-axis, and that is our horizontal asymptote. Okay, so let's go back to the rules again. So we are following the first rule here, finding the vertical asymptote. That's the first one. And we got x is equal to -1. And then we follow the second rule, 2a. If the numerator has lesser degree than the denominator, then there is a horizontal asymptote. So that horizontal asymptote there, it's y is equal to 0. And that's what our answer was. Okay. And we don't have slanted asymptote because slanted asymptote can be obtained if you have higher degree on the top and then the bottom is less than the top. So for 2b, if the numerator and denominator have the same degree, then we can have a horizontal asymptote. Y is equal to an. So where your an is the leading coefficient on the top, and that's our an here. Our bn, it's the leading coefficient at the bottom. So when the degree on the top is the same as the degree at the bottom, then you can have this horizontal asymptote. So it's not y is equal to 0 anymore. Okay, so a while ago, our f of x is equal to 1 over x plus 1. So this one cannot be applied because this one here, it's x power of 0, and you have power of 1 here. So the top is lesser than the bottom. the condition for 2b here, the numerator and denominator should be the same degree. Okay, so we will have an example on that one. So again, we cannot apply the first one. We only have 2a that we can apply there, not 2b. 2b for the same degree. And let's have an example here. Okay, example, if you have f of x is equal to um, let's say you have x here over x minus 2. So that would be our example. Okay, so doing that, you'll be asked to find all the asymptotes here. So the first one is finding the vertical asymptote. So vertical asymptote would be setting the bottom equal to 0. So we have the denominator here, which is x minus 2. So x minus 2, set that to 0, and then x is equal to 2. So that would be our vertical asymptote. Now note your answer should be aligned. It should be x is equal to 2, not 2. 2 is only a point. Okay, so our horizontal asymptote here, okay, according to the rule that's in 2b, it says if the numerator and denominator have the same degree. So we have the same degree now. This is power of 1 on the top, and this is power of 1 at the bottom. So we have again same degree. And the function in is a form. So we will actually get a y for the horizontal asymptote and then set that to the leading coefficient of the top and the bottom. So the leading coefficient here is 1, and we have also 1 here. So our horizontal asymptote would be y is equal to 1 over 1, or just 1 divided by 1 is 1. So that would be our horizontal asymptote. Slanted asymptote is none at this point. If there is horizontal, there's no slanted. So note for these two equations here, x is equal to 2, so that's the vertical line passing through the broken part of the graph, and this is y is equal to 1, a horizontal line passing through the broken part of the graph also. Okay, so let's show you the graph here. Okay, so this is from the previous example. Our second example is x over x minus 2. Okay, so our vertical asymptote was x is equal to 2. So you can see the purple line here is passing through the point 2, which is the broken part of the graph, and that is our vertical asymptote. Okay, and the horizontal asymptote is y is equal to 1, because we have to take the leading coefficient on the top divided by the leading coefficient at the bottom. So 1 divided by 1 is a 1. And you can see the black line here, which is the horizontal line. It's the horizontal asymptote. vertical, the purple one, and the black one is the horizontal asymptote. So since we have horizontal asymptote here, we don't have slanted or oblique asymptote. Okay, so let's go back to the last rule, which is 2C. Okay, so let's switch our screen to the last rule. Here it says if the numerator is of degree exactly 1 more than the denominator, so you have the degree here, it's exactly 1, okay, more than the denominator. So that's the numerator there, denominator. Then there will be an oblique or slanted asymptote. Okay, so we will have that, and we have to divide the numerator by the denominator and disregard the remainder. Set the rest of the quotient equal to y. So you're just going to say y is equal to, and whatever your quotient. So quotient should be placed here. So just ignore the remainder. Again, quotient should be placed here. Y is equal to. Okay, so let's show you an example for this one. If there is a slanted, there's no horizontal at this point. Okay, so vice versa. So if there is horizontal, there's no slanted. But if there is a slanted asymptote or oblique, there's no horizontal asymptote. Okay, so let's take an example. Um, let's say your f of x is equal to x squared minus 5 over x plus 1. Okay, so here you have your f of x, which is your y, equals x squared minus 5 divided by x plus 1. So you have a rational function here. And note from the rule there, it says if the numerator is of degree exactly 1 more than the denominator. So the top here, the numerator, that's 2 power, and here you have a power of 1. No power is understood as power of 1. So you have a 1 there. So the top is exactly 1 degree higher than the bottom at this point. So we have a slanted asymptote here. Okay, so first let's find the vertical asymptote. Vertical asymptote is setting the bottom equal to 0. So that's x plus 1 equals to 0. So therefore x is equal to negative 1. So that's our vertical asymptote. Horizontal asymptote, since we have slanted here, because the degree in the top is higher than the bottom. So horizontal asymptote, we don't have it, so none. For slanted asymptote, the rule here is, or oblique asymptote, is to divide the top divided by the bottom. So we will do that. So that would be our dividend is on the numerator. So that's x squared minus 5 divided by x plus 1. So we will take the uh, first term divided by the first term of the divisor. So x squared divided by x is x. X times x is x squared. X times 1, it's x. And then we subtract. Subtracting this, the first term would be a 0. And remember, there's no x here. So that's x power of 1, the next term. And it's not there. So that would be a 0 there minus x, that should be negative x. We bring down negative 5 or minus 5, and then we do the same process again. We divide negative x divided by x, only the first term of the dividend divided by the first term of the divisor. Again, negative x divided by x is negative 1. So negative 1 times your x would be negative x. Negative 1 times 1 would be negative 1. And then we subtract. Subtracting this would be a 0. And negative 5 minus negative 1 would be a negative 4. We don't care about the remainder here. So this is our remainder, but we don't care about the remainder. So we only care the top. So we have here the quotient. So we set y is equal to x minus 1. And that would be our slanted asymptote. Again, it's x minus 1. And don't forget that's a line, so we have to include y there. So to complete your answer for the slanted one, it should be y is equal to x minus 1. And that is a slanted line passing through the broken part of the graph of your f of x. Okay, so we will show you the graph next. So here's the vertical. Think about x is equal to negative 1. That's our vertical asymptote. We don't have horizontal, and we do have slanted. So if there is slanted, there's no horizontal. So our slanted is y is equal to x minus 1. So we will show those two equations next. Okay, so let's have the given f of x here. So we have x squared minus 5. And the bottom part would be x plus 1. Okay. And our answer was, our vertical asymptote was setting the bottom equal to 0. So that would be x is equal to negative 1. And we'll try a different color so you can see it clearly. X is equal to negative 1. So it's a blue line that's passing through the broken part there. So as you can see, that is exactly the location of the vertical asymptote. And you can see in the top, the red curve is approaching the blue line, which is our asymptote. And at the bottom is the same thing. The curve is approaching the blue line. So that's exactly our asymptote there. And our horizontal asymptote is none. We don't have one because we have slanted. Why is it we don't have one? Also, it's because the top degree is higher than the bottom. You have a power of 2 here, and you have a power of 1. And we divide this polynomial, x squared minus 5 divided by x plus 1 to get our slanted asymptote. And our slanted that we solve, the quotient was x minus 1. So we put y in front of that. Y is equal to x minus 1 now. And that's the green diagonal line that's passing through the broken part of the graph. And as you can see, as I move my graph here, the red curve is approaching the green line but never touches that one. Same thing over here at the bottom. So that's exactly the asymptote. Note if you miss that part, let's say you have x minus 2 as your answer, you will know that you miss it. As you can see this part here, the diagonal line, which is our slanted asymptote or oblique asymptote, is intersecting now the graph. So that is not the right one. So you will know that when you graph your function, your f of x. So the correct answer was x minus 1. So always check your answer by graphing, and you will know you got the right answer by looking at the exact location of the asymptote. Okay, if it touches or intersects, then you miss the calculation. So you just have to redo your calculation and check where you miss. Okay, so those are the three. So that's finding the asymptotes: vertical, horizontal, and slanted or oblique. So just follow those rules and then double check your answer by graphing.